Let's talk about prime numbers, composite numbers, and the numbers that are neither prime nor composite. There are three types of number. One, they are prime numbers. Second, they are composite numbers. Third, they are neither prime nor composite. How to know the number, the whole numbers of this kind? Let us see. Prime and composite numbers are all about multiplication. What are they basically? They are all about multiplication. It's not about addition, okay? Prime and composite numbers is not about addition. It's all about multiplication. Multiplication vocabulary states that the two numbers being multiplied together are each called factors. For example, if we say there are two numbers, 2 into 3 equal to 6, then this number 2 and 3 are called factors. What is this number 6? The number 6 is called the product. Okay, the multiplication, the answer in a multiplication problem is called the product. Okay, so let's take an quiz here. Which option represents the factor for the sum 4 into 3 equals 12? Is 1 the right answer, or is 2 the right answer, or the 3 right answer? Is it only 3 right answer? No, right? So 3 is also a factor. Is 12 the right answer? No, because 12 is a product. Product is the answer. This is the answer, hence 12 is a product. Is 4 and 3 the right answer? Yes, 4 and 3 are the factors of for this problem 4 into 3 equal to 12, because 12 for 12 4 and 3 are factors. 12 is the product. So that is the idea. In short, multiplication is about factor multiplied by factor, it gives a product, equals a product. That is what is multiplication. Okay, so for example, if you take 2 multiplied by 3 equal to 6, these 2 and 3 are called factors and 6 is the product. Okay, to find out what is a prime number, or to determine the prime number, or to determine if a number is a prime number, you have to place the number in the product position. For example, we have to place it here. Okay, now we have to determine whether this number is a prime number. From here we have to find the factors of this number. As per the rule, one number has to be 1, right? We found that one of the factor has to be 1, other has to be a whole number other than 1. It should not be the 1, okay, other than that. Okay, that is the rule. So must have only 2 possible. What are the rules pertaining to the prime numbers? Number 1, the prime number must have only 2 possible unique factors. Unique means individual. Like for example, 1 into 2, they are two different. It is called unique. Unique means they should not be the same. They should be different. 1 is not 2, right? Therefore they are unique here. But 1 into 1 is what? 1 is to 1 is going to be non-unique. If you take 1 multiplied by 1, they are same. So they are non-unique. They are identical. Identical means same. Okay. So they both should have 2 possible unique factors. Both factors cannot be the same. They become non-unique. Okay, if they are same, they are called identical. What is the second point? One factor must be 1. Okay, among the two, there are 2 factors. One should be definitely 1. What is the third requirement? One factor must be a whole number, but not 0 or 1. Remember, this is important. Okay, it cannot be 0 or 1. Okay, that is it. So here we got, this is how it looks. One of the factor would be same number of the product. Okay, we have 3 here. Okay, this factor has to be the same number as the product. The other factor is 1. So 3 into 1 is 3. There should be no other number which can give the product. But in case of 4, is there any other number? 4 into 1. If we want 4, how do we write 4 here? We do is, if you take 4 here, yes, the one of the number is going to be, one of the factor is going to be 4. Then there is 1. 4 into 1 is 4. Is there any other number that gives the product 4? Yes. What is that number? You can have 2, right? What is the number that gives the same thing? It is going to be 2 into, what is the number again here? It's going to be 2. 2 2s are 4. So there is another possibility, right? There are 2 factors for 4. So this does not satisfy the first rule. Only 2 possible. But here we have 4 into 1 and 2 into 2. There are 4 possible ways, right? So here this one factor must be 1. But here we have the other factor is going to be 2 as well. Okay. So it failed in the second aspect. What is the third one? One factor must be a whole number. Okay, that is okay. That is satisfied. But it failed in 2 points. So 4 is not a prime number. Okay. So what is a whole number then? We talked about whole number here, right? So we just touch base. We know that you all know what is a whole number. Just in case if you don't know, look at it. Whole numbers are the natural number along with 0 and the natural numbers, okay, which starts at positive 1. So 1, 2, 3 is natural number. If you include 0 to it, then it's called a whole number. This you all know, right? So now prime numbers, if you take the case of a 3 here, you see the 3 is 3, the same number, and 1 is there, so this is a prime number. 3 is a prime number because there are only 2 possible unique factors. Unique means, exactly, it should be, say, it is individual, it is not same, they are not identical, they are different. That's called unique. They are different and they are non-repeating is called unique. Are they repeating? No. 3 is different, 1 is different. Therefore, they are unique. And there is only 2 possible. Can 3 have any other factors? No. Only 3 has 3 into 1 and 1 into 3. So no other 2 numbers multiply together have a product of 3. And both factors are different numbers. So 3 and 1 are different. One factor is 1. So it satisfies this. One of the factors is 1. Other factor is a whole number and should not be 0 or 1. Yeah, 3, right? So it should not be 0 or 1. So prime numbers, there is a common mistake or misconception. Conception means idea. Misconception means wrong idea. Okay? There is we always presume all the odd numbers are prime numbers. What are odd numbers? We know 1, 3, 5, 7, 9. Come on, very good. These are all odd numbers. We always think these are all prime numbers, right? There is a misconception. What is the misconception? Wrong idea. So they are always not all odd numbers are not prime numbers. Some odd numbers may be prime numbers, like 1 to 7 could be prime number. 3, 1 is not a prime number. 3 and 3 to 7 could be prime numbers. But 9 is not a prime number, right? Let's find out. We found out that some odd numbers, like 9, have more than 2 factors. The first 2 factors are 9 into 1. There are 2 factors. But 3 into 3 is also gives 9, right? So there are 4 factors. So consequently, what do you mean by the word consequently? Because of that. Okay, consequently, because it has more than 2 factors, it's called, other way we can say it, consequently, because of the reason stated above, 9 is not a prime number. 9 is not a prime number. But if you take 51, it's tricky. If you take 51, it is an odd number. It looks like only 51 into 1 gives 51, right? But if you go deep, if you divide 51 by what? 3. If you give 3, you will find 1 times 3 is 3. Therefore 2 here, and bringing down this 1 below, we will have then 21. So how many times 3 is 21? 7 times, right? Minus 21 equals 0. So 17 is a factor. 17 into 3 is the another way of writing 51, right? So therefore, how many factors we see? There are, other than these two, we got 2 more factors. So 51 is not a prime number. There is a small hint. What is a hint? Hint is a clue. C-L-U-E. Hint means some support, some clue. Okay. Divisibility rules and multiplication tables. If you go into divisibility rule and multiplication table, they can help you discover whether that a number that seems like a prime number really is not. Okay. Even though it looks like a prime number, this is not a prime number. So prime numbers, however, even numbers are predominantly, everything is a non-prime number. All even numbers are not prime numbers. They are never a prime number. But there is only one exception. Exception means only one that is that defies the rule. Defy means one is outside the rule. 2 is a even number, but is also a prime number. But for 2, if you take any other even number like 2, 4, 6, 8, etc., etc., but for this 2, every other number is not a prime number, because 2 is there in every other number, right? The reason is 2 is a prime number because the only 2 factors of 2 are what? 2 times 1 is 2, that's all, nothing else, right? But every other even number has 2 as a factor, right? We followed that.